Yes, today we embark on an electrifying journey through the captivating worlds of electrostatic and electricity. These are the phenomena that surround us every day, yet they hold secrets and wonder waiting to be unveiled. Electricity is the invisible force that powers our modern world, from the lights that brighten our homes to the devices that connect us across continents. It is the spark that drives technological innovations and fuels our progress. Meanwhile, electrostatics, on the other hand, is the realm of electric charges at rest. It is the science behind those fascinating moments when a balloon sticks to the wall or when your hair stands on end after a winter waltz. It is the study of the invisible forces that shape the world around us. Today, we will delve into the core concept of electrostatic and electricity, exploring the nature of electric charge, the behavior of electric currents, and the fascinating interplay between the two. We will uncover the law and principle that govern these phenomena from Coulomb's law to Ohm's law and understand how they impact our lives. So, fasten your seatbelts as we embark on a journey through electrostatics and electricity and let the spark of knowledge ignite your curiosity. Electrostatic. On the concept of electric charge, fundamental property of matter. It comes with two types, positive and negative. Like charges repel each other and opposite charges attract. Based on Coulomb's law, describe the force of attraction or repulsions between two charged objects. The force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. On part of electric fields is a region of space around an electric charge where another experiences a force. It provides a way to describe the influence of a charge on its surroundings. Electric potential and voltage is the electric potential energy per unit charge, and it is a fundamental concept in electrostatic. Voltage, measured in volt, represent the potential difference between 2 points in an electric field. Electrostatics and conductor and insulator. Nucleus contain proton and neutron surrounded by several electrons orbiting it. Charge carrier are electrons and proton. Protons are tightly bound within atomic nucleus. They could not escape and move freely as an isolated charge. The process of removing an electron from an atom is known as ionization. In a metallic material, the electrons are detached from their atomic orbits and allowed to move freely within the sea of positive metallic ions. They carry charges very quickly from one end of the metal to another. This is the reason why metals like copper, gold, silver are regarded as a good conductor of electricity and used in manufacturing of electrical wires and cables. In non-metallic, the electrons remain tightly bound in atom, unable to travel freely, and non-metals exhibit poor electrical conductivity and are called electrical insulator. They are often used as covering for electrical wires and devices to protect the users from electrical shock. Electrostatic Let's look into electrostatic induction. This is a process where the distribution of charges on an object can be rearranged by the influence of nearby charged object without direct contact. Meanwhile, electric potential energy is the electric charges possesses electric potential energy based on their positions in an electric field. This energy can be converted into kinetic or other forms. Electrostatic has a wide range of applications in our daily life, including functioning of electronic devices, the operations of capacitors, and behavior of material in electrical circuit. Electrostatic paint sprayer. Example in the diagram, as the paint leaves the spray gun and the tiny droplet of paint become positively charged as the electron transfer out of the paint droplet into the needle, the surface of the painted metallic object is then given high voltage negative charge, which extract the positively charged paint droplet. And let's look into the photocopier. This is the process where the main of the document is projected onto a positively charged copying plate. Then, when light falls onto the plate, the electrical charge leaks away. And negatively charged black toner particles are attracted to the remaining positive area. Paper is placed over the copying plate. Toner is transferred to the paper and heated to make it stick. And the photocopy is taken off the copy plate and turned over to reveal the text. This is how photocopier works. And you have to place basically the original document on top of this screen. Electrostatic precipitators. Electrostatic precipitators are used in industries for environmental protections in factory, power plant, and chemical plant smoke, and other exhausts have to be treated to remove the particle before it releases to the atmosphere. Working as electrostatic precipitator, where you have smoke particles pick up a negative charge. At the bottom part is a waste gases containing smoke particles. And then you have a smoke particles pick up a negative charge. Then smoke particles are attracted to the connecting plates. And then waste gases without smoke particles come out from this area. And this part is actually the collecting plates are not to remove the smoke particles. If you can see, the dotted line is actually negatively charged metal grade. Electricity is the study about moving electrical charge current. Current is rate of flow of charge. Current is a rate of flow of charges. So the unit that we use is ampere. Standard unit or standard international unit is ampere. The equation for current is I equals to Q divided by T. I is actually represent current in the unit of ampere. Q is actually charge. And T is actually time. In an electric circuit diagram, conventional current, which is independent of the type of charge carriers is needed, flow from the positive terminal of the cell to the negative terminal. So for the conventional, the current flow from positive to negative. When scientists discover that electrons are the actual charge carrier, they become out another term called rate of electron flow, which travel from negative terminals to positive terminals. These directions for the electron flow is directly opposite to that of the conventional current. So to measure current, an ammeter is needed. To make emitter work perfectly, positive terminal of emitter should be connected to positive terminal of the cell and connected to the series of cells. This is how the diagram looks like. Electromotive force. Electromotive force is the total amount of energy required to carry or drive a single unit charge around entire electrical circuit, also called as total potential difference or voltage in circuit. And the formula is V equals to E divided by Q, where V is a voltage, E is the energy, and Q is a charge. Potential difference voltage is the amount of energy required to carry or drive a single unit charge from one point of the electrical circuit to another point, or difference of electric potential between 2 points. So the standard international unit is volt. When an electric charge is moving through the wires in the circuit, electrical potential that drives its motion is slowly converted into other forms of energy like heat. Electrical resistance, based on Ohm's law, states that voltage across the conductor or resistor must be directly proportional to the amount of current passing through it. V equals to IR, where V is a voltage, I is a current, and R is a resistance. Resistance is electrical conductor that opposes the flow of electrical current. R equals to resistivity L over A. R represents resistance. I equals to wire length. A is a cross-sectional of a wire. And P is a resistivity in a form of ohm meter. An electron charge travel in a longer wire would experience a greater amount of resistance. Electrical power and energy. Electrical power is given by formula P equals to E divided by T. You break down the equations to become P equals to E divided by Q times Q divided by T. Based on the previous lecture, please recall P is equal to VI. To calculate the power, where P is electrical power in the form of what? V is a voltage in the form of volt, and I is a current in the form of ampere. Electrical power can be calculated by the area under the voltage current. Given electrical energy equals to E equals to PT, and you simplify, you get P equals to VIT, where E is electrical energy and T is a time. These are electrical circuit symbols. Two types of electrical circuit. We have series and parallel. This is actually the electrical circuit symbol. This is a conductor's crossing, no connection. This symbol is referring to junction conductor. Open switch, single cell, battery, AC power supply, DC power supply, transformer, emitter, voltmeter, fixed resistor, variable resistor, fuse or circuit breaker, heater, thermistor, light dependent resistor, LDR, diode, light emitting diode, lamp, loudspeakers, microphone, electric bell, earth or ground, motor, generator, and the capacitor. Circuit symbol. Cell is actually supply electrical energy. The larger terminal on the left is positive. DC, the function is flow in one direction. AC, flow in both direction. Switch, allow current only to flow when the switch is closed. Resistor is a restrict the flow of current. And rheostat is used to control of current. Meanwhile, lamp and bell is a transducer which converts electrical energy to light and sound. You have a microphone, milliampere, and voltmeter is used to measure current and voltage closely. Relay is a form of secondary switch that is closed or open indirectly. Electromagnet in another circuit. Diode is a semiconductor which acts like conductor when the current flow in the right direction become resistor. Motor is a device that converts electrical energy into kinetic energy. Transformer is a two-coil of wire linked by an iron core used to increase and decrease AC voltage. Energy is transferred between the coil by magnetic field in the core, and there is no electrical connections between the coil. Fuse, a safety device which will blow melt if the current flowing through it exceeds a specified value for breaking the circuit. Generator is a device that converts kinetic energy into electrical energy. This type called a series circuit, where you have battery connected to resistor, resistor 1, resistor 2, and resistor 3. A series circuit is characterized by a constant current throughout the circuit path and the conservation of electric charge, ensure that no charges are lost or gained as they pass through the various components in the circuit. The sum of all potential differences across each individual resistor is Vt equals to V1 plus V2 plus V3. V1, V2, and plus V3, where Vt is electromotive force or total voltage. So if you want to get the potential difference across the resistor using Ohm law, IRT equals to IR1 plus IR2 plus IR3. Simplify, it becomes RT equals to R1 plus R2 plus R3. For the parallel circuit, this is how parallel circuit looks like. In parallel circuit, the current split up at junction point with different branches leading to individual resistor, and then it comes back together at junction point before turning to the source. Each branch represents a separate path for current to follow because of the conservation of energy and the conservation of electric potential. The total electric potential voltage provided by the electric cell is the same for each branch in parallel circuit. The voltage across its resistor remains constant. So the sum of all potential difference across each individual resistor is become Vt is equal to V1 equal to V2 equals to V3 equals to V. Voltage, the total voltage. The current join 7, which means the current join 7, the same as the current join 2. So IT equals to I1 plus I2 plus I3, where IT is a total current flowing in the circuit, I1, I2, I3, the current flowing in the first resistor, and so on. Based on the Ohm law, I divided by RT equals to I divided by R1 plus I divided by R2 plus I divided by R3. Uses and action of circuit component. Previously, we did understand some of the function, and now there is another function for the component of the circuit. For the thermistor, this is the sign of thermistor. It's a type of resistor whose resistance is dependent on the surrounding temperature. At low temperature, resistance thermistor is high. At high temperature, the resistance of thermistor becomes low. This is a symbol for light-dependent resistor. Is dependent on the light intensity received by resistor. In the dark resistance, LDR is high. Light-dependent resistors is high. Under bright light, the resistance of light-dependent resistor becomes low. This is a symbol for diode, where at this point you have anode, and at the end of this point on the right-hand side is a cathode. It's a semiconductor resistor that directs current to flow in a single direction in the circuit. When current flow in the direction as specified, is known as forward bias. Reverse bias when current flow opposite direction. This is a symbol for relay. Relay is a secondary switch operated by electromagnet connected to electrical circuit with small electrical power to power source used to control large sources of electrical power which are too dangerous to be operated directly. This is a symbol for potentiometer. It's a voltage divider used for measuring electric potential. This is a sign for capacitor, a component that are used to store electrical charges and used in time delay circuits. Commonly used as a battery and in electronic circuit for blocking direct current while allowing alternating current to pass. And this is a symbol for transistor as three terminal. We have emitter, we have base, and we have collector. Emitter is the outlet for that supply. Okay, you can see the arrow here. And base is the gate collector device for larger electrical supply. Meanwhile, collector is the larger electrical supply. That's all for today's presentation on the electrostatics and electricity. Hope that you do understand. And hope to see you in the next presentation slide. So wish you all luck in your study and hope to see you in the next presentation slide. Thank you very much.